Here says in the unit circle alongside Q corresponds to the angle theta. A. Write down the coordinate of Q in terms of cosine negative theta and sine negative theta. First of all, look at the unit circle here, P. Reflect across the x-axis. So the coordinate, we will see the coordinate, the first terms doesn't change. For example, if I have here x and y, when I reflect across x-axis, I will have x and negative y. That means x doesn't change, but for the second term, we'll get a negative sign. Same size, but negative sign. When my reflection is across the x-axis. So here first it says write down a coordinate of Q is so easy. So I write the first term would be cosine of negative theta and sine of negative theta. Sine of negative theta. Which is here cosine of negative theta and sine of negative theta. Q is the reflection of P in the x-axis. I said reflection of P in the x-axis. Use this fact to write down the x-coordinate of Q in terms of cosine theta. So when I have a reflect across the x-axis, x doesn't change. For P, x is cosine of theta. So cosine of negative theta equals cosine of theta. Now I will go for part 2. The y-coordinate of Q in terms of sine theta. As I said, y only change its sign. So sine of negative theta, it works for all angles. Sine of negative theta equals negative sine of theta. Negative sine of theta. Parsi says hence establish the negative angle formula. Negative angle formula says cosine of negative angles equals the cosine of theta. And sine of negative theta, oh gosh, sine of negative theta equals negative sine of theta. Part is right tangent negative theta in terms of tangent theta. Tangent of negative theta equals sine of negative theta over cosine of negative theta. As I said, sine of negative theta gives me negative sine of theta, negative sine of theta, and over cosine of theta, which is negative tangent of theta.